Hello and welcome. In today's video, what we're going to be talking about is probability trees. And in fact, we're going to be taking them down a little bit of a harder track than what we have in class. So previously I've talked to you about how to structure our normal probabilities. And in general, when I talk about the two different types, we talk about those probabilities that involve with replacement and those that are without. Okay? So I won't keep you waiting. Basically, when we talk about this particular thing, the first example I'm going to go through will be just our general example that we've covered before. Okay, so there's a bag of 15 marbles, 5 are red, 6 are blue, and 4 are green. Okay, we're going to construct a probability tree. Remember, this is just a way of organizing out our probability experiment so we can visualize it, okay, by drawing 2 marbles at random. So when we see drawing 2 marbles at random, we know we're going to have 2 stages to our probability tree. And the next important word that we see is with replacement. Now what this means is that we're basically taking a bag, we're drawing out of it, and whatever we get we put immediately back in. Okay, that's the whole idea behind with replacement. Now with replacement problems are generally considered a little bit easier. Okay, so for our probability tree we know we have 2 stages, but we have 3 different outcomes: a red, a blue, and a green. Okay, so that means we have 3 different branches. So from our draw in our first stage, we have red, blue, and we have green. Now try and line these up if you can, right, and keep your tree diagram neat. All right, so stage 1, we have red, blue, or green, and then for each one of these draws, our second draw could be a different color or the same. So we could also have a red, we could also have a blue, we could also have a green. All right. Again, going down here, red, blue, or green, and a red, blue, or green. Okay, I ran out of a little bit of space. I don't quite have room with the Sharpie that I'm drawing with at the moment, okay? But try and keep it neat if you can and go across the page. All right, now a probability tree needs probabilities, okay? Well, you'll notice that we have 15 marbles, 5 of which are red. So on our red branch, we put 5 out of 15. Okay, we have 6 blue marbles, so 6 out of 15, all right, and then 4 green marbles. Okay, what you'll notice, if you want to make sure that you've done this correctly, each of these branches in your individual segments should add to 1, right? So 5 15ths plus 6 15ths and 4 15ths will add to 15 over 15, which is 1, okay? And it should work for each of these individual sections as well, okay? So when we do this, the next step is to then go on. We notice it's with replacement, so the probabilities of drawing out any individual marble does not change. We still end up with 5 15ths, 6 15ths, and 4 15ths. Now you'll notice that mine's getting a little bit small, unfortunately. Alright, I do apologise. Okay, I'll try and make that a little bit bigger for you to see. Alright, again, down here on the second draw, again we have 5 15ths, another one with 6 15ths, and another one with 4 15ths, okay, just as we walk down. All right, and finally we figure out the last one. Again, nothing's changing. 6 15ths, and on the final one we have 4 15ths. Okay. Now, when we're doing this particular example, right, we're going to look at question 1. All right, where it talks about what is the probability of drawing a red then a blue. So this is where we go to our diagram and we follow the trail. Basically, it asks us what's the probability of drawing a red then a blue. Notice that we're going along the branches, okay? So it's asking us to draw, so it's asking us to use the word and, right? So a red, then a blue. So 5 15ths multiplied by 6 15ths because we're going across the branches, okay? So probability of red, then blue. Okay, notice that I've just shortened that down to just be the letters, is equal to our 5 15ths multiplied by our 6 15ths for our next branch. Okay, notice this is being very specific about the order. It wants the red first and then the blue. It's counting that as a distinct event. Okay, so when we do that, we just end up putting this into our calculator to simplify down, which after simplifying down will give you 2 15ths as your final answer, right? So a 2 in 15 chance of drawing a red then a blue. Okay. So, moving on to the next one, just as a rehash to sort of understand what we're talking about, it's asking us what's the probability that 2 of the same colour are chosen. So we need to go back up to our tree diagram. This is why they're so useful. For 2 of the same colour, pay attention to my language here. We have red and red, or we have blue and blue, or we have green and green. When I use the word or, that means we add, because we are working down the tree diagram and going across red and red, right? We multiply. Going down, red and red, or blue and blue, we add, okay? So basically what we're saying is P of red and red, so the probability of red and red, or blue, blue, or green, green is equal to all of them added together. So probability of red, red, plus probability of blue, blue, plus probability of green, green. Okay, so let's put this together and do some calculations. Okay, so the probability of red and red is 5 over 15 times by 5 over 15, just following along that branch. So that's 5 over 15 times 5 over 15. Plus, now we go for blue and blue, so 6 over 15 multiplied by 6 over 15 because we're working across. Okay, plus because now we're doing OR, all right, the 4 over 15 times 4 over 15 for the green, green. So 4 over 15 times 4 over 15. Tidy this all up, okay, put it into your calculator, and you should end up with an answer of 77 over 225. Okay, you have a 77 out of every 225 chances of achieving the same colour being chosen when you draw that out of your bag of marbles. Okay, so let's consider this experiment again. Okay, however, in this particular case, what we're now going to do is each time we remove the marble from the bag, okay, we're not going to put it back in. Okay, you'll notice that in this particular case it says without replacement, so we're not putting the marbles back in the bag. All right. So again, we're going to go down the path of constructing a probability tree. We still have the red, the blue, and the green outcomes. So we still have 3 branches, and we still have 2 stages to our probability tree. Okay, but we're going to construct them slightly differently. Okay, so let's draw our 3 branches. Red for our first, blue, and then green. Giving yourself plenty of space to work with, unlike what I did in our first example. All right, and then again for our second stage, red, green, and blue. So red, green, and blue, red, green, and blue, red. Oh, my apologies. I might quickly fix this up, try and keep everything consistent. Red, blue, green, just to follow what we're doing in the first stage. Okay, my apologies. Blue and green, blue and green. Okay, here is where these problems become a little bit more difficult, is actually filling out the probabilities on the tree. Okay, let's think about the first stage. In this stage, we haven't drawn any marbles out of the bag. So to draw any of the marbles out, the probabilities remain the same. So remember, we had 5 out of 15 red, we had 6 out of 15 blue, and we had 4 out of 15 green marbles. When I take a marble out, remember now we no longer have 15 marbles, so everything inside of the second stage will not be out of 15, it will instead be out of 14. Be very, very, very careful for this because it means your probabilities change. Okay, so if I've taken a red marble out, I now have 14 marbles left. Okay, but I've taken a red one out, which means I now only have 4 red marbles left. So I have a 4 in 14 chance. Okay, we can work along the same thing with the blue line, right? So we've drawn a red marble out in this case. We haven't touched the blue marbles. In this particular case, remember there's 6 blue marbles remaining. So we now have a 6 out of 14 chance. Okay, the same thing with green. We haven't touched the green, so we have a 4 out of 14 chance. My advice to you is when you go through and you rewrite out this new probability tree, take some time for yourself to set yourself up and work along each of these branches. All right, a little bit of time here will save you pain later on in the questions. Okay, so let's do the blue one, right? I advise you to start again. So 6 out of 15, we've now drawn a marble out. We have 14 left. So all of these will be out of 14. It's worthwhile remembering that. Okay, so when we talk about all of these being out of 14, I've drawn a blue out. I have not touched my red. I now have 5 out of 14 left. Same thing for blue now. I had 6. I'm now left with 5 out of the 14. And then with green, I haven't touched them. So I had 4. I'm now left with 4 still. All right, and then again with the final one, okay, it's out of 14, out of 14, out of 14, the same premise. 5 out of 14 red, 6 out of 14 blue. However, we've now drawn one of the green out, okay, so we only have 3 out of 14 left, okay. Taking some time to set your probability trees up, all right, are going to save you a lot of hassle. So, let's now look at this particular question. What's the probability of drawing a red then a blue? Now remember, this is the exact question that we did last time. All right, a red then a blue. All right, let's just see how the probabilities change now that we're not putting marbles back into the bag. So probability of red then blue is equal to, we start off with a 5 over 15 and multiply by 6 over 14. 5 over 15, now multiplying by the new probability of 6 out of 14. You plug that into your calculator, you do a little bit of simplifying, and you'll notice you get 3 out of 21. Okay, that's different to our original answer that we achieved of being 2 out of 15. Okay, so it's worthwhile remembering that when we do experiments without replacement, okay, or where the probabilities change, okay, your answer will be different. So you have to take the time to set this up. Okay, so let's do the last one here. You can pause the video and have a go at it yourself if you like, or you can just follow along with me. So the probability that 2 of the same color are chosen, this is exactly like what we did last time. That's the same as me saying probability of red, red, plus probability of green, green, plus probability of blue, blue. Okay, all right, it's completely and totally up to you how you set this out. All right, that's just following red, red, blue, blue, and green, green, okay, going along there, okay, where we add them together. So now, this is where it takes a little bit of time, all right? So we're going to do red, red, which is 5/15, all right, multiplied by the 4/14. So 5 out of 15 multiplied by 4 out of 14, plus now we'll do, because I've written it in this way, green, green, and we'll come back to blue, blue. We're going to write 4/15 multiplied by 3/14. 4/15 multiplied by 3/14, plus, and we're now finally going to do blue, blue, 6/15 multiplied by 5/14. Once you put all of this into your calculator and you do a little bit of simplification, you should end up with an answer of 31 out of 105. Okay, it's worthwhile taking some time. Remember, these tree diagrams are here to help you out with complex problems. Okay, in the next part of this video, I'm going to talk a little bit more about different styles of problems, and we're going to do some HSC questions together. Okay, I'll see you shortly.